Hey guys, Mr. Alent here again. I'm going to do one more video for you real quick on how to graph polynomials. I just showed you a video for factoring polynomials. Let's look at graphing polynomials. I'm going to show you two examples here. Try not to go too long on this again so you're not watching too many videos of me, but let's see a couple examples of when we graph polynomials. So here we go. The first example we're going to do is this polynomial right here. We're going to have negative 2x cubed, or is it minus 2x cubed? Negative 2x cubed, plus 6x squared, plus 2x minus 6. And I'm just going to give you the factored form. We could go through the process. We would take out a GCF, we'd factor by grouping. But it factors as negative 2 times x minus 3 times x plus 1 times x minus 1. Okay. That's how it factors. And we do need the zeros. So let's go ahead and really quick find the zeros. So again, we would set this equal to 0. You got negative 2, x minus 3, x plus 1, x minus 1. And then again, the resulting multiplication can only be 0 if one of these is causing that. So the x minus 3 could be causing the 0, the x plus 1, or the x minus 1 could be causing the 0. This negative 2 is not causing the 0, right? If there's an x attached out there, we would care, but because it's just this constant, if I divide it by negative 2 right now on both sides, this side would still be 0. This negative 2 has no effect. It's just doing a vertical stretch or compress for us. So we add 3 to both sides, right? Just solve these simple one-step equations real quick and get our zeros. So we have a 0 of 3, negative 1, and 1. Okay, now when you're graphing, there are some key components that we need. And these are rough graphs, I will say. These are not exact graphs. We're not getting the exact look of it or the exact placing of every little number on the graph. We're just trying to get a rough guess, a rough idea of what this looks like. So we need to talk about the degree of the polynomial, the leading coefficient of the polynomial, and we need to talk about what's called the end behavior. So we say as x approaches negative infinity, p of x is approaching question mark, and that's what we're going to fill in a second. And as x approaches positive infinity, p of x is doing something else. And I'll explain that a little bit better in a moment. We call this, by the way, again, the end behavior. End behavior. Okay, we need to know the zeros, which we just found conveniently. We need to know what's called the multiplicity, which we get from the zeros. And we also need to know, is it crossing or bouncing? And that's in reference to the x-axis. Are we crossing the x-axis or are we bouncing at the x-axis? And that's determined, again, by the multiplicity. So the zeros are important for telling us where our graph crosses the x-axis. Multiplicity then tells us, are we crossing or bouncing at that x-axis spot, that location of that 0. Okay, so let's look at the degree of this polynomial here. When it's in standard form, like it is up here, the degree is just it's the highest power. It's the highest power you see, highest exponent. So the highest power we see is 3. And what really matters to us, though, is that power odd or even? And this is an odd power. Why that's important? If it is an odd power, then the two ends will be going in opposite directions, right? One will be going up, one will be going down. All right, so if it's odd, they go in different directions. If it's even, they go in the same directions. Okay, and then we look at the lead coefficient. We have the lead coefficient is the number multiplying your lead term, so that's a negative 2. But again, actually what's more important than the number itself is it positive or negative? And this is negative. And why that's important is it's going to more or less flip the direction. Normally, the left side, so let's talk about the end behavior here. As x approaches negative infinity, now this is, you're kind of thinking input versus output, right? X is like you're putting this in, the p of x is like your output, you're getting out. But remember also, x on a graph, right, that's a horizontal thing, right? So basically, one way to think of this is, as x goes to negative infinity, that's like saying, as we go left, as we're going to the left forever, what's happening with this guy? And this is, again, like y, right? It's our output, and it's a vertical thing. So what's happening as we go to the left? Vertically. What's happening as we go to the right? Positive infinity. What's happening as we go to the right? Vertically. And normally, if it's not negative, this side would be going, the left side's going down, the right side's going up. Because the negative, they're going to flip. And so our left side will be going up to positive infinity, and our right side will be going down to negative infinity. Okay? The zeros we had up here, and I'm actually going to write them. I like to put them in order from least to greatest. So we're going to do the -1, then we had the 1, and then we had the 3. Okay, and let's talk about the multiplicity. Now remember, multiplicity, when you go up here to factored form, that's the easiest time to see it. You're looking for, does something occur more than once? You know, is there more being accounted for here? And really, you could think of each one of these as like to the first power. Something to the first power is just itself, right? So x minus 3 to the first, x plus 1 to the first. These are all being accounted for only once, these zeros. And so they all, in this case, have a multiplicity of 1. Every one of those has a multiplicity of 1. Because it didn't, and you'll see in another example when the multiplicity is not 1. And what happens is, if the multiplicity is odd, like this, 1 is an odd number. If the multiplicity is odd, then we cross at those zeros. All right, if the multiplicity happens to be even, we would bounce at that 0. Okay, we've got all the information. Let's go ahead and graph this guy and see what it looks like. Okay, so I'm just getting my axes here. We got x and y. We need a scale. 1, 2, we're going up to 3. All right, so we got a -1, +1, 2, 3. And again, if you graph the zeros first, that's usually how I start, right? We know that we are hitting the x-axis at least at -1, 1, and 3. At -1, +1, and at 3. Okay. We know that through each of those zeros, we are crossing. I'm going to put a little C next to each of those so we remember that we are crossing through. We're not bouncing. We're crossing through, going through the axis. And on the left side, right, as x goes to negative infinity, we are going up. So from this guy, we are going through it and up. On the right side, as we go to positive infinity horizontally, we are going forever down. So this guy is going to be crossing through and going down. So then the question is, what happens in between? And what's cool about these graphs is that they do a lot of turning and curving. And so this guy came up through, but we know it has to come back and cross here. So this is going to basically make a flip around and come back through this guy right here. And then we know it has to come back and attach to this. So we kind of get another little flip around. And we get that rough sketch. Now we could find better what's happening between these zeros. If we built a table and we started inputting values, we could know a little bit better what's happening between, but this is just our rough estimation. We know we're going to get this kind of S curve going on here, heading in these directions. Okay, so there's one example. Let's look at another. So this next example, here's our polynomial. We're going to do x to the 4th minus x squared. This one factors, again, I'm just going to give this to you so we don't have to spend the time on it. You can look at the other video, as x squared times x plus 1 times x minus 1 is how that would factor. We need the zeros. Let's go ahead and find those. Okay, so we set it equals 0, and then anything that's multiplying that could create the 0, we have to account for. So the x squared could be making the 0. The x plus 1 could be making the 0. I don't need parentheses, but whatever. Didn't mean to put them in there. They're there. It's all right. Square root both sides, so x is 0. Subtract 1 from both sides, x is a -1. Add 1 to both sides, x is a +1. There are our zeros. We'll need those in a second, just like you saw in the previous example. Okay, and so like before, we need to identify the degree, the lead coefficient, the end behavior. So as we go forever left horizontally, what's this guy doing vertically? And as we go to the right, what's happening vertically? We're going to need the zeros, the multiplicity from those zeros, and then that tells us whether we cross or bounce on our graph. Okay, the degree up here. Our degree looks like it's a degree 4, which this one is an even. Again, the odd or even is really what matters more than the 4. It's even, so we know that these two guys, they're actually going to be the same, right? With odd, they go in different directions, but even, they go in the same direction. So we'll need to figure out what the direction is in a second. We look at the lead coefficient for that. There's nothing there, but you can always think of there like being a 1, right? So we have a lead coefficient of 1. 1 times something is always itself. And again, that's a positive. Now, because it's positive and even, we know these are both going to be going up. All right, positive direction is up. So this is, if you think about a quadratic, which we spent a lot of time on, quadratics or parabolas, they always open in the same direction, right? So that both ends are going in the same direction, either up or down. Positive means we're going to be going up, okay? The zeros, again, put them in order. I knew looks like -1, 0, and 1. The multiplicity, okay, the -1 came from here, and again, if you go back up to where it came from is the x plus 1, that's like an x plus 1 to the first, so it has a multiplicity of 1. The 0 came from this guy, the x squared. Now, this is the intriguing piece. The x squared, when you square root something, usually there's 2 roots, and so it's almost like it pulls 2 things. It's got a magnitude of 2, and so this is where we are going to have a multiplicity of 2. The 0, I know the square root of 0 is just 0, but because that was an x squared, it's like it's doubling up. This is creating more or less 2 zeros, and that's our multiplicity of 2. The positive 1 root, or 0, came from the x minus 1 term, which again is like to the first, so it's got a multiplicity of 1 as before. So, again, if it's an odd multiplicity like the 1s, that's where you cross. If it's an even multiplicity like 2, that's where we're going to bounce. And we'll see that in just one second here, what that looks like. Okay, so we're going to get our graph. And we plot our zeros. We got a -1, we got a 0, and we got a positive 1. And if we kind of quickly just put in here what we saw, the -1 we are going to cross. At the 0, we're going to bounce, right? We're going to bounce right there. And at the 1, we're going to cross. Okay, and look at the end behavior here. We are going to be going up. So we're crossing through -1, but we're going up. So it's going to cross through and do this. Okay, on the right side, same idea. We're going to be crossing through and going up. So it looks like that. And again, these are going to turn back towards this other 0, but at the 0 we bounce. So we're not crossing through. These went all the way through the axis. The bounce is where we kind of just come in and touch it. It's like the axis is what's called a tangent line right there. Boom. We just bounce, we hit it once and come right back. Okay, and we get that little W shape. And that's that. Whew. There's a couple examples of graphing polynomials. Again, these are rough sketches. They're not perfect, but they give us a really good idea of what this more or less looks like. Hope that helps as you're working through this week's stuff. Good luck, guys.